Welcome to OStats, a platform for short statistical hacks. This video will cover effect size. The effect size helps us to objectively assess whether there are meaningful differences, because ultimately what we want to know is how important an effect is that we find. It may be significant, meaning we can reject the null hypothesis, but is the effect really meaningful? Effect sizes are calculated on a common scale to facilitate comparisons between studies, between variables, or between scales of measurement. Or said another way, the effect sizes are standardized. For example, an effect size based on temperature can be compared to an effect size based on blood pressure, or an effect size for writing in words can be compared to an effect size in reading in time. So we see that it does not matter what has been measured or how they have been measured. Effect size is constrained to sit between 0, meaning no effect, and plus or minus 1, which is a perfect positive or negative effect. So you have standardization, which converts different measures into a standard set of units between -1, 0, and +1. The unit of measurement that is used in standardization is the standard deviation, which is the average deviation from the mean, and it is represented by this +- symbol. There are a number of ways to express effect sizes. Expressing the degree or the strength of an association between two variables is expressed as the R, although for those experimental researchers out there, the R can also be a measure of the strength of an experimental effect. Expressing the proportion of variance explained is expressed as R squared, whereas expressing the degree of difference between means is expressed as D. The R is the Pearson's correlation coefficient. R squared represents the odd ratio, and D represents Cohen's D. The Pearson's correlation coefficient effect size can be small, medium, or large. For example, an effect size of 0.10 is small and explains 1% of the total variance. An effect size of 0.30 is medium and explains 9% of the total variance, and an effect size of 0.50 is large, as it explains 25% of the total variance. But it is important to note that the scale is not linear, so 0.30 is not 3 times larger than 0.10. The Cohen's D effect size can also be small, medium, or large. For example, an effect size of 0.20 is small and explains 1% of the total variance. An effect size of 0.50 is medium and explains 6% of the total variance. And an effect size of 0.80 is large and explains 16% of the total variance. Finally, a meta-analysis combines effect sizes from different studies that are essentially addressing the same research question or theory or hypothesis, and this is done to improve estimates of the population effect size. You do this by calculating the weighted average of the effect sizes across the studies of interest. And that's OStats. If you like this video,